In previous video, we have discussed about formation of PDE, formation of partial differential equation. So in this video, let us discuss about solution of partial differential equation or solution of PDE. How to solve when a partial differential equation is given. So let us consider A naught dou z by dou x plus A1 dou z by dou y plus A2z equal to some f of xy. Let it be a general partial differential equation. So when we got this, so obtaining through the process of integration or through some method, if you get the expression in z x y, so if you get the expression in z x y, so that is called solution of PDE. This is called solution of PDE. So again, the solution itself is called integral of PDE. So integral can be expressed in two ways. So we can classify into two types. One is general integral, another one is particular integral. So only if it is having z term, x term, y term, it is called particular integral. So otherwise, particular integral. So instead of this, along with z, x, y, if it involves some arbitrary functions f of y, g of x like this, it is called general integral. Solution itself is called integral. We classify into two types. One, if it is having some arbitrary term, it is called general integral. If it is having only z, x, y term, it is called particular integral. So let us understand one by one. So we classify partial differential equations into two types. Those are, one is homogeneous PDE, another one is non-homogeneous PDE. So here in this module, you are going to learn both solution of homogeneous PDE and solution of non-homogeneous PDE. So we know homogeneous means only dependent variable z and its derivatives. Partial PDE will have only z term, z and its derivatives, whereas if non-homogeneous PDE means along with z term, the PDE will have independent variable x term. So such PDE is called non-homogeneous PDE. So now in case of homogeneous PDE, what we can do is, so already you have learnt how to solve the linear differential equations. That method, inverse differential operator method, the same technique we apply to solve homogeneous PDE. That is, we go for first substituting the derivative d by dx as capital D. After substitution, then we go for auxiliary equation, roots of auxiliary equation, then nature of roots, we write solution. So in case of non-homogeneous PDE, whatever the derivatives are there, like dou z by dou x or dou square z by dou x square, so through the process of direct integration, remove the differential operators and you are going to get the solution z in terms of xy or expression in terms of xy. So that itself is called solution of non-homogeneous PDE. So let us understand in detail how to solve non-homogeneous PDE. So here in this case, we go for solution of non-homogeneous PDE by the technique called direct integration. So whatever the derivatives exist in the PDE, those derivatives or differential operators, we need to remove it by direct integration. So let us understand through some basic examples. So example, solve dou square z by dou x square equal to x plus y. So if this is the example, so how to solve it? So look at this, it is having z and x and y. So it is called non-homogeneous PDE. So now if you look at derivatives, so partial derivatives, so it can be written as dou by dou x of z equal to x plus y. So here the differential operators are with respect to x, which these two are operated on z. So to eliminate, what we need to do is through direct integration, eliminate these two derivatives and you will get expression in terms z in terms of xy. So now it is dou by dou x. So integrate partially with respect to x. So now, so when you integrate, so integration of differentiation of some term is integral and the derivative will get cancelled. So you are going to get dou by dou x of z, that is equal to integration with respect to x. So x square by 2 plus y is, if partial integration means other variable treat it as constant. So integration of constant is constant into x plus some constant, arbitrary constant. So that arbitrary constant will be which term? So here in case of partial integration, so we have treated y term as constant. So constant will be f of y term, not y term. So that's why we write it as f of y. So now, so this is what we got. So next is again dou by dou x is there. So this has to be removed. So integrate with respect to x partially. So again integrate. So if you integrate, so again the partial derivative is removed. So you will get z. Integration of x square by 2, x square integration x cube by 3 into 2, that is 6, plus y is constant, integration of x is x square by 2 plus y term, f of y means y term. So y term is constant with respect to x. So constant into x, f of y into x plus some arbitrary constant. So that constant will be y term, g of y. So this is how we get the solution of PDE. So let us understand another one. So simple example, let us consider another simple example. Solve dou square z by dou y square equal to x plus y. So in this case, how to solve it? So again, if you elaborate it, so it can be written as dou by dou y of z, dou by dou y of z. So now that is equal to x plus y. So here the derivative operator is dou by dou y. So through the process of integration, remove these operators. So for that, integrate with respect to y partially. So if you integrate, so one derivative is removed. So dou by dou y of z we get, that is equal to x. So x, if integration with respect to x term treat it as constant. So x constant into y plus y integration y square by 2 plus some constant, arbitrary constant. So that arbitrary constant here is, whenever you are integrating partially, x term. So f of x, not simply x term. So now we got this. So dou by dou y of, again operator, derivative operator, remove it. So for that, again integrate with respect to y partially. So if you integrate, dou by dou y will be removed. So you will get z. So y integration, x is constant, y integration y square by 2, y square integration y cube by 3 into 2, that is 6. So now integration with respect to x, f of x is constant. So constant into y plus arbitrary constant term g of x. So this is what we got the solution. So like this you need to solve all the problems. So now let us solve some question paper problems. Solve dou cube z by dou x square dou y equal to cos of 2x plus 3y. This was given in VTU June 2019 examination. So now how to identify? Solve, whenever solve is given, first identify which type of problem it is. So it is having z term, z and x and y. So if it is along with dependent variable z, if it is having x and y term, it is called non-homogeneous PDE. Non-homogeneous PDE. So in case of non-homogeneous PDE, we know what is the procedure. So that is direct integration method. Direct integration method. So here the differential operators dou x square dou y. So it can be written as dou by dou x, dou by dou x, dou by dou y of z. So that is equal to cos of 2x plus 3y. So now, so you need to remove differential operators so that you will get the solution z in terms of xy. So to remove this you dou by dou x, so integrate with respect to x. Integrate with respect to x. So if you integrate with respect to x, so this will be removed. So we get dou by dou x, dou by dou y of z. So that is equal to integration of cos is sin 2x plus 3y. Integration of 3y. So with respect to x means multiple of x is 2. So that you divide it. Divide by 2 plus some constant term. So that constant term is other variable term f of y. So this is what we got. Now if you look at this, again we have dou by dou x. So to remove this, integrate with respect to x. Integrate with respect to x. So if you integrate, so this will be removed. So this derivative will be removed. So you are going to get dou by dou x, dou by dou y of z. So that is equal to integration of sine. Integration of sine we know minus cos 2x plus 3y. So with respect to x integration, multiple of x you divide it. So already 2 is there, 2 into 2, 4 we get. Plus with respect to x, y term is treated as constant. So constant into x, x into f of y plus arbitrary constant some g of y. Let us consider g of y. Now you look at this dou by dou y. So differentiation with respect to y, so this has to be removed. To remove that one, integrate with respect to y. Integrate with respect to y. So when you integrate, this term will be removed. So you are going to get z. So z equal to minus sine integration of cos. Integration of cos is sine 2x plus 3y. But with respect to y, so multiple y is 3. So that you have to divide it. Already 4 is there. So 4 into 3, that is 12. Plus x into integration of f of y, integration of some arbitrary term f of y, plus into g of y, integration of g of y, plus some constant term. So that constant term is other variable term. So if integration with respect to y means x term, then let us consider h of x as constant term. So now z equal to what we get? Z equal to minus sine 2x plus 3y divided by 12 plus x into. So it is an arbitrary term which we don't know. So integration of that arbitrary term will be some capital F of y, small g of y, and it will be another term g of y plus some h of x. So this is the solution of given problem. Now let us solve another problem. Solve dou cube t by dou x square dou y plus 18xy square plus sine of 2x minus y equal to 0. So in this problem it can be rewritten as dou cube t by dou x square dou y, that is equal to, if you take xy term that side, minus 18xy square minus sine 2x minus y. So now look at the term. T is derivative differentiated with respect to xy. So t is dependent on xy, where dependent variable t is there and also it is having x and y. So that's why we can name it as non-homogeneous PDE. So in case of non-homogeneous, we know how to solve it. So if non-homogeneous is there, we go for direct integration. So for that, remove differential operators. So dou cube t by dou x square dou y can be written as dou by dou x, dou by dou x, dou by dou y of t. that is equal to minus 18xy square minus sine 2x minus y. So this is the term. So now through integration remove differential operators. So first dou by dou x. To remove that one, integrate with respect to x. Integrate with respect to x. So if you integrate, this term will be removed. So you are going to get dou by dou x, dou by dou I of t. So that is equal to, with respect to x means integration of x. So that is x square by 2. X square by 2. So 18 by 2 will be 9. So minus 9 x square y square. So integration of minus sign. Minus sign is plus cos. Cos 2x minus y. But a multiple of x is 2. So that in case of integration you divide it. Constant. So divide it plus arbitrary constant. So constant term will be, when you are integrating partially with respect to x, y term, f of y. So this is what we got. So now what you need to do is remove another differential operator. So dou by dou x. To remove this, integrate with respect to x. Integrate with respect to x again. So if you integrate, this will be removed. So dou by dou I of t. So that is equal to, with respect to x square integration. So x square integration is x cube by 3. So 9 by 3 is minus 3. So minus 3 x cube y square plus integration of cos, that is sine 2x minus y. Multiple of x is 2. So divide it. So already 2 is there. So 2 into 2, 4. Plus f of y term, integration with respect to x is there. So x into that constant f of y plus arbitrary constant g of y. So this is what we got. So now lastly what we have is dou by dou I. So for that, integrate with respect to y. Integrate with respect to y. So this will be removed. T will get. So y means with respect to y, other x term treated as constant. So y square integration y cube by 3. So 3 get cancels. So you will get minus x cube y cube plus integration of sine. Integration of sine is minus cos 2x minus y. But with respect to y multiple is minus 1. So divide by minus 1. So minus 4 plus x integration of with respect to y means integration of f of y, small f of y. So integration of g of y term plus constant. So with respect to y means x term is constant. So that we consider it as h of x. So t can be written as minus x cube y cube plus minus get cancels. So 4 cos 2x minus y divided by 4 plus x into some arbitrary term is there. So you will get another term. So integration of small f of y will be some capital F of y. Integration of g of y will be some capital G of y plus some h of x as it is. So this is the required solution of given problem. Now let us solve another problem. Solve dou square z by dou x dou y equal to sin x into sin y, given that dou z by dou y equal to minus 2 sin y when x 0 and z 0 when y is odd multiple of pi by 2. So now the thing is, very simple thing is, first identify which type of problem it is. So solve, it is having dou square z by dou x dou y equal to sin x sin y. So z is expressed in, z is there in this PDE as well as x and y term. So it is called non-homogeneous PDE. So in case of non-homogeneous, we go for direct integration. So it can be written as dou by dou x of dou z by dou y equal to sin x sin y. Now, so to remove this operator, we go for direct integration. To remove this operator, so integrate with respect to x. Integrate with respect to x. So when you integrate, this will be removed. So dou z by dou y equal to. So dou z by dou y equal to. So what we get? Integration of sin x. sin y is constant, other variable y term is other variable term, that is constant. Integration of sin x is minus cos x into sin y plus constant term. So integration with respect to x means y is treated as constant, so y term f of y, that is constant. So take this as equation number 1. So dou z by dou y equal to this we got. So here it has been mentioned that dou z by dou y equal to minus 2 sin y when x 0. So given dou z by dou y equal to minus 2 sin y when x 0. So substitute here, dou z by dou y is minus 2 sin y when x 0. So wherever x is there, put as 0. So cos 0, that is 1. So minus sin y you will get plus f of y. So now minus sin y, take this side. So minus 2 sin y plus sin y, it will be minus sin y. So f of y we get it as minus sin y, f of y. So this you substitute in 1. So from 1 dou z by dou y equal to minus cos x sin y plus f of y. F of y is minus sin y. So this is what we got, dou z by dou y. So once you get this, then what you need to do is now you need to remove this term dou by dou y. So for that, integrate with respect to y. So integrate with respect to y. So dou by dou y operator will be removed, differential operator, z you will get. So with respect to y, x term we treated as constant, sin y integration. So minus cos x sin y integration minus cos y minus sin y integration, so plus cos y plus arbitrary constant. So constant will be other variable term, that is f of x. So it can be written as minus plus cos x cos y plus cos y plus f of x. So take this as equation number 2. So z equal to this we got. So once you get this, then you go for us applying the condition. So it has been given that z0 when y is odd multiple, odd number means 2n minus 1 multiple of pi by 2, odd multiple of pi by 2. So now z0, substitute here z0. So cos y, so cos x, cos of 2n minus 1 pi by 2 plus odd multiple of pi by 2, y substitute cos 2n minus 1 pi by 2 plus f of x. So now substitute here, we have substituted the y term. So now identify what is the value of this. So odd multiple, odd number means what? 1, 3, 5, 7, like that. So if you look at in xy plane, odd number, so here pi by 2, so pi by 2, here also 3 pi by 2, odd multiple, so 1 pi by 2, 3 pi by 2. So again 5 pi by 2, odd number, 5 pi by 2 is again here, so 7 pi by 2, so 9 pi by 2, so 11 pi by 2, like this. So here and here, but cos pi by 2, so we know cos pi by 2 is 0 and cos 3 by pi 2 is also 0. So odd multiple of pi by 2 for cosine will be 0. So this term is 0. 0 equal to odd cos of 2n minus 1 pi by 2 is 0, that is 0. So f of x. So we get f of x 0. F of x 0. So once you get this, substitute here. So f of x value from 2, equation 2, z equal to cos x cos y plus cos y plus f of x 0. So this is the final required solution. Solve dou square z by dou x square equal to x plus y subject to the conditions dou z by dou x equal to log of 1 plus y when x equal to 1 and z0 when x 0. So this was given in VTU 2008 examination. So let us solve this. So look at first, whenever solve is given, so identify which type of PDE, whether it is homogeneous or non-homogeneous. So if it is having z, along with z, xy term, independent variables, xy, it is non-homogeneous. So in case of non-homogeneous, we go for direct integration. So now, so dou square by dou x square can be, dou square by dou x square can be written as dou by dou x of z, that is equal to xy. So now, to remove this differential operator, integrate with respect to x. So partially when you integrate, this will be removed, this partial derivative is removed, dou by dou x of z we get. With respect to x square by 2. So y is constant, y term is constant, so arbitrary constant will be f of y. So this is, take this as equation number 1. So this is dou z by dou x, but we have it has been given the conditions dou z by dou x equal to log of 1 plus y when x equal to 1. So substitute here, dou z by dou x is log of 1 plus y when x is 1. So put x equal to 1, x1 means y by 2 you will get, y by 2. So f of y equal to this, or sorry, f of y equal to, so take this side, so log of 1 plus y minus y by 2. So this is what we got, f of y. So once you get this, so substitute in 1. So from 1, so what we can do is dou z by dou y, dou z by dou x equal to x square y by 2 plus f of y log of 1 plus y minus y by 2. So take this, okay, let it be as it is. So now here dou z by dou x we have. So again dou by dou x is the partial derivative. Integrate with respect to x. So if you integrate with respect to x, so it will become z. So x square different integration, x cube by 3. So x cube by 3 into 2, 6 plus y term we treat it as constant. So constant into x into log of 1 plus y minus, so y by 2 is also constant, so y by 2 into x plus, so arbitrary constant c, or arbitrary constant is when you are integrating with respect to x term, sorry, y term, f of g of I, let us consider g of I. So take this as some 2, equation 2. So once you get this, so you go for substituting the another condition. It has been given that z0 when x0. So given z0 when x0. So substitute, so z0 when x0, substitute x0 plus 0 plus 0 plus g of y, or we get g of y equal to 0. So g of y 0, substitute into, from 2 z equal to x cube y by 6 plus x log of 1 plus y minus xy by 2. So this is the required solution.